Microcontrollers feel complicated only until you realize they are simply tiny decision makers, quietly controlling the world around you. Welcome to the Learning Studio, where we don't just teach subjects, we break them down to their core intuition so you understand why systems behave the way they do, not just how to write code or connect pins. Most students think microcontrollers, such as Arduino PIC or STM32, are advanced devices meant only for programmers or embedded engineers. But in reality, they exist to solve a very practical problem: how to give electronic systems simple intelligence and control. Instead of building separate hardware for every function, microcontrollers allow one small chip to sense, decide, and act based on instructions. To see this intuitively, think about everyday automation. An automatic door opens when you approach, a washing machine chooses different cycles, and a traffic light changes at the right moment. Behind all of these actions is a microcontroller reading inputs from sensors, processing logic, and controlling outputs like motors, lights, or displays. Without realizing it, you interact with microcontrollers every time a device responds intelligently to your actions. At a deeper level, a microcontroller is a complete system on a chip, combining a processor, memory, input-output ports, and timing units. Arduino focuses on simplicity and learning. PE controllers are widely used in cost-effective industrial applications, and STM32 offers high performance and flexibility for advanced systems. While their architectures differ, the core idea remains the same: execute instructions in real time to control hardware reliably. On a larger scale, microcontrollers form the backbone of embedded systems across industries. Home appliances, medical devices, automotive systems, industrial automation, and IoT solutions all rely on microcontrollers to operate efficiently and safely. As products become smarter, the role of microcontrollers becomes even more central. In real engineering practice, microcontrollers are used when building control systems, interfacing sensors and actuators, managing communication protocols, and implementing real-time decision-making. Understanding how to choose, program, and integrate them is essential for modern electrical and electronics engineers. These systems evolved from early embedded computing concepts and now power billions of devices worldwide. Now that you understand what microcontrollers are and why they matter, the next step is to explore embedded programming and real-time control, where software and hardware come together to create responsive, intelligent systems. And that's exactly what we'll cover next here at the Learning Studio.